Okay, we're on to A5, lesson A5. This is part one of collecting like terms. It's an important aspect to a lot of the algebra concepts, bringing things that are alike together. And it's big enough that I do need to divide it into two parts. Today is the basic level of that, the basics. Variable, we haven't defined that yet for our notes. And so a variable is a symbol that stands for something. And we evaluated expressions in the last lesson, substituting for x. Could be an x, could be a y, could be a z, could be anything. Here's a formula that you probably remember from pre-algebra and maybe middle school. A equals pi r squared, area of a circle. This variable is the capital A, which means the area of a circle, what the area is, and it equals pi, which is not a variable. This is a constant. It's a ratio is what it is, and we call it 3.14. That's the simple answer of what it is in terms of number. R is the radius, and the radius, as I've put in your notes talk about this, A and R will change based on the size of the circle. So if the radius increases, the area increases. And so they change depending on the size of the circle. So those are variables that we use there. Now we're going to do some of the fill in the blanks at the bottom of the page. Okay? In algebra, we tend to use x and y. So you can fill these into your notes down at the bottom. We often use x and y. Later on this year, we're going to do systems of equations, where we have multiple equations and multiple variables. We tend to use x and y for that. But any letter or symbol, that goes into the next blank, any letter or symbol can be used. So if we were doing a problem that involved tickets sold, how many tickets, we're trying to find out how many tickets the band sold for its show, we could use T for tickets that way. Okay, so variables could be anything. Now let's go on to the back. Why don't you flip on to the back side of the paper. And we have one more fill in the blank, because we're dealing with adding and subtracting. So the fill in the blanks at the top says to add or subtract, we must have like terms. And what that means is this. I've divided some categories out. Like terms, unlike terms. So you have those headers on your paper at the top of your page up here. And I'm going to give you some examples of like terms. I want you to take these down. And we're then going to kind of do some of the adding and subtracting with them, okay? So, like terms. 6 and 7 are like terms. They're numbers. They're whole numbers. They don't have to be whole numbers. They can be integers or whatever. But they're numbers without anything affiliated with them. Those are like terms. X and X are like terms. And I'm going to now throw one over to unlike terms. Okay? So, if we have 6 plus x, those two terms are unlike. They're not the same. Number and a variable. I'll give you another set of unlike terms. If we have x plus y, we cannot add those together. They are not like terms. You cannot add x plus y unless we know the value of x and y, like we did in the last lesson. You just can't add x and y. Here we're going to manipulate the other numbers around. These are like terms, 2a and a, and in this case I'm subtracting them. Okay, so 2a minus a. Let's do another pair of like terms. AB plus AB. You could add whatever this is plus whatever this is together. We're not evaluating. I can't stress that enough. We don't know what A is. We don't know what X is. We don't know what B is. We don't care right now. We're trying to simplify eventually with the like terms. That's what we're doing. X squared and x squared are like terms because they're the same. That leads me to something that's not like terms. You cannot add x squared plus x together. You can't. One more. I'll do this. 2x squared y plus 1x squared y. We can add those together like that. Okay? So now let's simplify these together. So what I want you to do, you should have these down in your notes, and we're going to simplify them. 6 plus 7 is easy. You've been doing that for a long time. So we just do the math on these. X plus x, that simplifies to be 2x. So I hope you can start to pick up the pattern here. X plus x is 2x. We have two x's together. 2a minus a is 1a. We've got two a's, we're taking away an a, we have 1a left. AB plus AB is 2AB. When we add, we'll say we have two of them together. Soon enough, we're going to do multiplication with our like terms. And I'll let you know what we do when we multiply. We'll deal with squares and things like that. AB plus AB means we have two ABs. Same with x squared plus x squared. 2x squared. We don't add the exponents in this situation, everybody. We don't. It's in 1x squared plus another x squared is 2x squareds. You may say this is easy, maybe you've done it before, but it's really critical not to make a mistake on this. Okay, so we have like terms. Let's add them. 2x squared y plus 1x squared y equals 3x squared y. We've got two of them plus one of them. We're going to get three of them. Okay, so you've got these in your notes here. Make sure that you're kind of keeping an eye on these. These are not like terms. They're not. Okay? So we can't add them together. 6 plus x stays as 6 plus x. Stays as x plus y. Stays as x squared plus x. A lot of students will do this. They'll think that you can make this into xy. You cannot do that. Not true. That's not math legal. This is not 3x or x to the third. You can't do either of those things. They stay the way they are. Okay? And this, 6 plus x, is not 6x. It's not 6x. So I'm hoping with this video that you're recognizing what is and what isn't like terms.